This is Advanced Algebra, Wednesday, December 13th, a B day, or Thursday, December 14th, an A day. So today we have our last day before the unit test. So looking at the warm up here, take a few minutes, let's hit pause and get going on the warm up. Take a few minutes. Whenever you guys are done, hit play again. So taking a look, in the first one, if you remember that ln of e is 1, that makes it pretty easy. X is 1. If not, remember log? ln is just log with a base of e. So I can rewrite it as e to the x equals e to the first, and x is 1. In number 2, I change a base. I go from log form to exponential form. 3 squared is x plus 1, so that's 9. X plus 1 is 9. We move the 1 over, we get 8. In 3, again, change base. X to the 1/2 is 3. That's a square root, so I square both sides. X is 9. In 4, 1/16, change a base. Log base 4, so that becomes 4 to the x is 1/16. Now, 1/16 I could think of as 4 to the negative 2, and that equals 4 to the x, so x is negative 2 there. In 5, a couple ways I could look at 5 here. The first way, I could move the 5 out in front, and I could write it as log base k of k, and log base k of k is just 1, so I get 5 times 1 or 5. Now, why is log base k of k 1? Well, when we rewrite it, meaning if I looked in and I said, all right, the base is k, I can write it in exponential form. That would be k to the x equals k to the 5th. So x is 5 there. So either way, however you want to do that one. In sim, number 6, base is 10. Even though it's our common log here, the 10 is there. So x equals 10 to the 3rd. That's 1,000. 7, change of base. X is 1 over 3 squared, which is 1 to the 9th. In 8, so this one we kind of looked at yesterday a little bit, where we can put these together. So my bases are the same, so I can put log base x of 2 times 32, or 64. Now I can change it. X to the 3rd equals 64. So what times what times what is 64? That's 4 here. In 9, I have a couple different things to do there. I'm going to move 10 down a little bit. So one thing I have to do, I'm going to move the 1/2 back up to the 4. I'm going to move the 2 back up to the 5. Basically the opposite of the power rule there. So I have log 4 to the 1/2, log 5 squared, log 2 equals x. 4 to the 1/2, that's the square root of 4, so that's just 2. 5 squared, that's 25. And now I can put all of these together. Log 2, log 25, log 2 equals x. When I'm adding, I multiply the numbers inside. So that's going to be log 100 equals x. It's a common log, so the base is 10. So I change it from logarithmic to exponential. That means 10 to the x equals 100, so x is 2. Looking at 10, there's logs on both sides, so it's log of something equals log of something. In this case, log base 2 equals log base 2, so that is 1 to 1, meaning if they're both logs, then the inside has to be equal as well. So 5x minus 3 is 32, and we get x is 7 there. So at this point, our warm-up's done. Looking at the test here, a couple things that you can see that's going to be on the test. Remember, this is on Moodle here, so you can pull this back up just under the advanced algebra page. If you wanted to pause it, take a look at the things that are going to be on the test, either Friday or Monday for you. So, quick review here. We have our properties that we looked at last class. When I have an exponent there, I can move it out in front. That's the log of a power. So it becomes x times log of a. And the second one, it's adding. The logs are the same, so adding is sum. Or when I put them together, it's being multiplied, so it's the log of a property. And then the last one, we have subtraction. Subtraction is difference. And when I subtract logs and I put them together to make it 1, we divide. So a over b, that would be quotient. So again, remember, how do we apply these, right? Because that's kind of the important thing here. So take a second, hit pause. So taking a look, we want to figure out which ones are the same. So let's see, I'm adding here. That means I'm going to multiply them, so it becomes log of 6. 8 and 4, that's 32. 2 log of 3, that's what? The 2 goes up, that's 3 squared or 9. Subtraction means division, so 8 divided by 4 is 2. Addition, 8 times 1, that's 8. And then 3 log 2, it's not log 5. I have to move the 3 up to be 2 cubed, which is log 8. So in this case, you don't actually use log 5. We go on to the next one now. We think about strategies here. How do I kind of approach these problems? So if I'm thinking about 2 to the x equals 5, the things I look at, where is the variable? In this case, the variable is in the exponent, so to get it out of the exponent, I'm going to take the log of both sides. If I look at the second one, I'd probably put those together, get it log 5x, and then use exponential form. And the last one is log equals log, so that's 1 to 1. In the next one here, looks like I'm going to move the 2 up, and it's subtraction, so that's dividing here. Those are properties that I'm going to use. And then the thing I look at is this. I have log on the left side equals log on the right side. They're both bases are the same, so that's 1 to 1. 32 over 16 has to equal x. The stuff inside the log has to equal the stuff inside of the other log. In the next one, put the 3 up, so it becomes 4 to the third. That's 64, and that's addition, so that's 64x here. At this point, do I have logs on both sides? No. So what can I do? I can rewrite it in exponential form. So that's going to be 2 cubed is 64x. 2 cubed is 8. Okay, and we go on from there. And the last one, I have an x in the exponent. So eventually I'm going to have to take the log of both sides. So take a second, pause this, give these two a shot. So taking a look at this, the x is in the variable, so take the log of both sides. Remember, you could take the log or you could take the natural log, either one. So what that happens is the x can go out in front now, and then I divide by log of 2. So basically I have 3 steps. 1, take the log of both sides. 2, bring the x out in front, or the variable out in front, and then divide by log 2, which is really just a number. Now, why can we do that? Because they're both log base 10. I have the button on the calculator that can calculate log with a base of 10. Our exact answer, log 5 over log 2. If we wanted the decimal approximation, we could. And the second one, I'm going to put those together. It's addition, so that means multiplied. It's log base 10, so I'm going to rewrite it as 10 squared is 5x. And eventually I get x is 20. So, taking a look at the next one here. In this one, both of them are log. So I have log of something equals log of something. That means the insides have to be the same. So x is negative 3. In 4, it's an order of operations problem first. Get rid of the 12 by adding 12. Get rid of the 3. It's multiplying by 3, so I would divide by 3. Then I get 4 to the x equals 21. At this point, look, where's the x? The x is in the exponent. So what do I have to do? Take the log of both sides. I chose to do the natural log, ln. So now the x is going to come out in front. X times ln of 4 equals ln of 21. ln of 4, that's just a number here, so I divide by the natural log of 4. So I get x is the natural log of 21 divided by the natural log of 4. That's my exact answer here. I could have also wrote x equals log of 21 over log of 4. Both of them give you the same answer, remember. So, hit pause. Take a minute, think about the closure. So in the first one, what strategy to get the variable down? We take the log of both sides. That allows us to apply the power rule, which means I'm going to take that exponent, bring it out in front. So like in this case, I take the log of both sides. Now I can bring the x down out in front. R times log of 3 equals log of 26. So first step, take the log of both sides. Second step, bring the r out in front. Third step, divide by log of 3. Your answer, r equals log of 26 divided by log of 3. Just in case you forgot how to divide, there it is. So again, 3 steps. First step, take the log of both sides. You could take the log or the natural log, either one. Second step, move the variable down. So move the variable in front. Third step, divide by the log of 3 here. And then you could leave it as your exact answer, log of 26 divided by log of 3. That'd be fine. All right, so in 3. Probably the most difficult one because the first thought would be to add 3, but you really can't do that because we can't do log base 5 of 80. So I'm going to have to change to exponential. And then I'm going to have to take the log of both sides. I chose the natural log because it's one less letter and I don't want to write more. So I have log of 80 equals log of 5, x minus 3. I divide by the log of 5. So x minus 3 equals ln of 80 over ln of 5. And then I move the 3 over. So I have natural log of 80 divided by the natural log of 5 plus 3. So at this point, a couple things. Reminder, test. Next class. Okay. The rest of the time, you'll be doing the activity. You don't have to get stamps because I'm not there, and the sub doesn't have to go around. The answer keys are up on the boards. As you can see, it's a pretty long packet. Once you get done with that, you can start working on the chapter review. If you have the test on Monday, I'll be around about 7:30 in the morning. On this test, unlike the quiz, this test you can use a calculator on everything. I'll have half sheets for you if you want them, but you really don't need them. But you will have to have a calculator on all of it.